previous video of the vernier calipers, we have done the introduction to the vernier calipers and described the different parts of the vernier calipers and their function. In this part of the video, we will learn how to measure the dimensions of an object with the help of vernier calipers. So let's get started. Again, I am going to tell you about the principal and least count of vernier calipers. This instrument works on a simple principle known as the vernier principle. According to the principle, a given length x is divided into n-1 and n smaller divisions, each division of the different lengths, which are represented by two scales as shown. Let us say the distance of 9 mm is divided into 9 divisions on one side and 10 divisions on the other side. Then 10 divisions of scale B is equal to 9 divisions of scale A. 10 into B is equal to 9 into A. Scale B is equal to 9A by 10. B is equal to 0.9 divisions on scale A. Here the upper scale A is called the main scale and the lower scale B is the vernier scale. One vernier scale division is equal to 0.9 main scale divisions, as the length of the main scale divisions is equal to 1 millimeter. Then one vernier scale division is equal to 0.9 millimeter. Therefore, each vernier scale division is shorter than the main scale division by 1/10 of one main scale divisions, or 0.1 millimeter. Yes, as you can clearly see, the first mark of the vernier scale is short by 1/10 of the main scale division. This 10th mark at vernier scale is short by 10 by 10th of main scale division, and therefore 10th division of vernier scale coincides with 9th division of the main scale. Now let us try to move the vernier scale very slowly from left to right. Now the zero of the vernier scale is moved to the right marginally, and the first mark of the vernier scale still does not coincide with the first mark of the main scale. In this case, we cannot measure the displacement. Now, we try to move the zero until the first mark of the vernier scale coincide with the first mark of the main scale. Now, we can firmly say that the displacement of zero vernier scale from zero main scale is 0.1 millimeter, because first mark is 0.1 millimeter shorter of one main scale division, as explained before. Now we move even more further such that the second mark of the vernier scale coincides with the second mark of the main scale division. The distance between two zeros is 0.2 millimeter, because the second vernier scale division is 0.2 millimeter shorter than the second main scale division. Similarly, when the 10th mark of the vernier scale division coincides with the 10th of the main scale division, the distance between them is 1 millimeter. Therefore, the distances are of order 0.1, 0.2, 0.3, 0.4, 1 millimeter, or 0.1, 2, 0.1, 3, 0.1, and 10, 0.1 millimeter. This we can say that the least distance that can be measured accurately by the vernier calipers, also known as the least count, or the vernier constant, is 0.1 millimeter. The distance is nothing but the difference between one main scale division and one vernier scale division. When both zeros are coinciding, this least count is equal to one main scale division minus one vernier scale division. In a vernier calipers, where n divisions of the vernier scale is equal to the n minus 1 divisions of the main scale divisions at any given length, one vernier scale division is equal to n minus 1 by n main scale divisions. Substituting the value of one vernier scale division in the equation, least count is equal to 1 main scale division minus n minus 1 by n main scale divisions. Simplifying the equation, we get least count is equal to 1 by n main scale divisions, which is length of one main scale division by number of divisions of vernier scale. After obtaining the least count of the vernier, let us proceed to calculate the length of any given object. Now, let us say a very small object of length x is placed between the jaws. In order to find the length of the object, we need to calculate the distance between the two zeros in order to find the length of the object. We need to calculate the distance between the two zeros. This can be obtained by subtracting the length from 0 to coincidence of main scale division and vernier scale division, and length from 0 of vernier scale to coincidence of vernier scale. Here, it is 7 main scale divisions minus 4 vernier scale divisions. This can be written as 3 main scale divisions plus 4 main scale divisions minus 4 vernier scale divisions, which is 3 main scale divisions, plus 4 into main scale divisions minus vernier scale divisions. 3 main scale divisions is equal to reading that can be measured by the main scale. Therefore, it is main scale reading. It is 3 mm as one division of main scale is 1 mm. Now, this portion is the extra portion between the 3 main scale division and the 0 of vernier scale, which would be measured by the vernier scale, and is nothing but 4 into main scale division minus vernier scale division. 4 is the vernier coincidence. Main scale division minus vernier scale division is the least count or the vernier constant as calculated before. It is 0.1 mm. 4 into 0.1 is equal to 0.4 mm. Thus, the length is 3 plus 0.4, which is 3.4 mm. This is the formula for total reading is given by main scale reading plus vernier scale coincidence into least count. We use this formula to find out the total reading measured by the vernier calipers. Zero error. In some instruments, we usually find in laboratory suffer from excessive wear and tear, and also due to the manufacturing defect, the zero of the vernier scale do not coincide the zero of the main scale. It is either right or left of it. So, let us say in the given instrument, say vernier calipers of A with the zero of the vernier scale is to the right of the zero of the main scale. In this case, a particular division of the vernier scale coincides with the division of the main scale. Now, this can be understood as the vernier calipers is already measuring a certain length, as if an object is placed in between its jaws, even though no object is being held now. The extra distance is the extra reading the given vernier calipers is measuring. An extra length than the actual length when an actual object is to be measured. Thus our interest is to measure this extra length. Now, in this device, for example, an intersecting point is observed that the fifth division of the vernier scale is coinciding with the division on the main scale, when it normally should be at 0.5 mm to the left or right of any division. We can say that this extra length, which is wrongly measured by this vernier calipers, is 0.5 mm. Therefore, we reduce this length of 0.5 mm from the observed readings to obtain the actual reading. This type of error, in which the 0 is to the right of the 0 of the main scale, is called as the positive zero error. The correction we make is called zero correction, and in this case it is negative zero correction.
This reading can also be simply obtained by using the formula we discussed before. Total reading is equal to mean scale reading plus least count into Werner coincidence. Here, mean scale reading is equal to 0, least count is equal to 0.1 mm, and VR near coincidence is equal to 5. Therefore, zero error is equal to 0 plus 0.1 into 5, which is 0.5 millimeter, and this 0 correction is minus 0.5 millimeter. Similarly, when the 0 of the Werner scale is the left of the 0 of the mean scale, it actually measures less length than the actual length. Now, let us see, for example, in this given vernier calipers, the 0 of the vernier scale is to the left of the 0 of the main scale, and the 6th division of the vernier scale coincides with the division of the main scale. But in the normal devices which are free from the 0 error, the 6th division is actually at 0.4 mm ahead of the main scale division. Thus, we can conclude that this particular device measures a less distance of 0.4 mm. This, in order to obtain the actual reading, we need to add this to the observed reading. This type of zero error is called the negative zero error, and the correction is positive. As usual, this error can also be calculated using the formula main scale reading is minus 1 mm, Werner coincidence is equal to 6, least count is equal to 0.1 mm. Therefore, error is equal to minus 0.4 mm, and the correction is plus 0.4 mm. I hope from this video the function of the Werner calipers and description of its different parts is clear to you all. The least count and both types of zero error is very well clear to you all. In the next video, we'll discuss about the screw gauge and its functions. Till then, take care, study well and be safe.